All right, so this is the third time of what is the name of this study group? Practice daily English. So let me remind the purpose of this team. So as Enjoying Math YouTube channel is expanding, so this channel is already quite famous in South Korea when it comes to talk about the not just the bachelor level of mathematics, but this covers indeed the spectrum of mathematics from the not just the bachelor level, but in the very like the elementary level to the graduate level and even professional level of or like the diversity of mathematics. And weekly basis, there are around 30 weekly like the study groups. And what I was able to understand is as long as one can just discuss one by one, little by little, then everyone can really enjoy with their own pace of learning mathematics. And I honestly believe that this should be expanded to the not just a Korean-based conversation, but also not only even English-based, but even beyond. So that I'd like to try to put my effort to expand the small group of the discussions, either not just based on English, but even also, so that in order to do it, I'd like to define the group of the practicing the language. And this is the very like the starting point that the people from the previous like the study groups, they can try to express what they have learned in the weekly basis in English. And then I will also put the effort to invite the people who can give the like appropriate feedback in terms of mathematics and if necessary in English as well. So this like the third time of the study, I invite my very precious friend Lisa so that you can call her either, I don't know, Lisa or Professor or Dr. Naples as you prefer. So we met in 2016 from the one graduate class at University of Connecticut, and we share a lot of like our like the personal like the life as a graduate students and after beyond. And so I'm very like happy to introduce Lisa at this point. I believe that not just the from this like the recorded like the session, Lisa could contribute this like the not just this community, but the community of the mathematics in her own way to let people enjoy their own pace of like learning things in mathematics. So the way of the making conversation today would be following. I first like to let Lisa to introduce herself, and I'd like to first Bo-hyun to speak what he prepared. And also Yusuf can also express what you wanna say. Then Lisa can provide the feedback in your own way. And then the speaker, so starting from Bo-hyun, can like the point it out the next speaker, or you can suggest, then we can just turn around. And once each of the speaker the speak what they prepare, then Lisa can provide her own like your own feedback, and then we can just turn around for everyone. That's the style of this conversation. So Lisa, why don't you introduce yourself and we can go over.
Sure. So my name is Lisa Naples. I went to grad school at University of Connecticut. I graduated in 2020. And currently work at a liberal arts institution. So it's mostly focused on undergraduate students in Connecticut, which is not too far away from University of Connecticut, where I went to graduate school. Um, I currently work at the school that I went to undergrad to get my undergraduate degree at. So I'm very happy to be here. Um, my job is like a mix of teaching and research. My research is in geometric measure theory slash analysis in metric spaces, kind of areas. And yeah, I am very happy to be here. And we also mentioned that, yeah, maybe during the summer we will have some sort of reading group if people are interested in geometric measure theory related things or analysis on metric spaces. So I'm happy to talk to people about that at some point as well.
Great. Then Boyan, you can first like go over what you prepared.
Okay. Hello, my name is Bohyun Cho, and as my classmate Josep introduced, we are studying applied mathematics in Germany. And since we are international course, so we have a lot of international students, like Josep from Egypt, and next to him there is German, our classmate, and yeah, and also the other classmate who is from Russia, he is also interested in our community. So I'm really appreciate that we have this opportunity to, as my classmates can be also join this community. So yeah, I really appreciate with that opportunity, and it feels a bit weird just I have to read my script just next to my classmate, but anyway, I will start to reading my yeah script. So this week I had the opportunity to attend an insightful seminar led by Mr. Park on the topic of power series, focusing on particularly popular application to using these power series representations to handle integrals. What I found truly remarkable is that even when an antiderivative of function is unknown, we can utilize its power series representation to apply the fundamental theorem of calculus. By treating the infinite series as a polynomial, we can integrate in term by term, allowing us to calculate definite integrals for functions that would otherwise be impossible to solve analytically. While this practical application is clear, I'm still trying to clarify my understanding of pointwise convergence and investigating which specific classes of function cannot be represented as a power series. I would like to express my sincere thanks to Mr. Park to presenting this subject. Thank you. And do you have specific, maybe like how you like our courses or how you learned
I just
math in Egypt, like your
yeah,
always
I just want to tell more about my like my story with mathematics. Like started as a primary school, we always take mathematics as a subject was just a bunch of formulas and numbers, and we don't really understand as children how can we handle or how can this like ex affect our life in practical like examples. But the thing is why I choose like applied mathematics in university as a major. I wanted like I always had an interest in mathematics as long as like interest in programming as well. And I thought like applied mathematics as a major, it's not like pure mathematics would be I would say appropriate choice for me. And I'm really curious about mathematics, like because when I study more mathematics, I started to see some kind of patterns or relations between different areas in math, like calculus or linear algebra or different uh, places in mathematics. And the more I study, the more I feel like okay, it's all about connected together, and I don't really understand like how is it connected, or is it the way we define the science itself, or it's just like we discover it? That's something I really I still don't understand it, but that got my interest in terms of studying different areas in math. Yeah, that's
okay. So
Yeah,
so we
before
have
Lisa give her own like the feedback, I'm wondering because not just the two of you, there is a one additional friend next to you. I'm just wondering the next one also wanna
you
introduce
want to
more.
introduce yourself and like what?
Hello,
And,
good day. My name is Josiah. I'm from Germany and I too study applied mathematics here.
and like how you can speak like four languages?
Well, I
Like
speak three,
yeah,
three
yeah.
German, English, Spanish, and I'm learning currently Russian.
And like maybe your interest about like math or
I enjoyed mathematics in school quite a lot and also the calculation part, which is why I chose applied mathematics rather than pure mathematics to still have some calculations to enjoy rather than 100% of pure mathematics. Yeah, so I'm sort of in between uh, proofs on pure mathematics and engineering due to the calculation part, which is not as heavy if you study pure mathematics, of course. Yeah,
All right,
that's fine.
Lisa, now it's your turn.
Right. Well, thank you all. First of all, I love that you're all there together. I think Gunny knows that it's like math community is something that I also care a lot about, and like bringing people from different perspectives and backgrounds all together to share in some sort of common common goal, I think, is something that I really appreciate. And I know being part of the math community has provided me with access to a lot of different people that I would have never met if I hadn't stepped into the math world. Like it's much made my world much larger and much more global. So I love that that you are all there together studying in the same room. Um, I also was very interested to hear about your experience with being applied mathematicians. I think my background is in very theoretical math, and um, it's kind of helped me. I mean, when I was younger, I really liked this kind of separation between actually my math and the real world. It was kind of like I used my math for an escape. But recently, I have been teaching a lot of engineering students, the undergrads, and sometimes the master's students as well. And the more that I teach them, the more I feel this like excitement that some of you are talking about of like connecting real world like engineering questions and things like this to the math aspects as well. Um, I am also very happy to hear that you like power series in particular because this is a topic that my students they never like, and I always feel I have to I have a hard time inspiring them. So to hear your interest in this inspires me. Hopefully, I can bring some of that excitement to to them to see how useful this really is as a tool. Yeah, and I think the more you learn about the application, I recently yesterday was watching some of my students. They made robots that had to navigate paths, and I was talking to one of the engineering faculty members, and he was telling me about all the math. So I think yeah, the more you learn, the more exciting it can be.
Thank you for your comment.
Okay, if Boyan's two
Yeah.
friends had no like the additional comment, then Boyan can suggest the next one to speak.
So we have to pick. Do we have any?
Um,
Okay. We will pick Mr. Song-Hoon Kang to next speaker.
Um, okay. Am I supposed to introduce myself first?
Yes, please.
Okay. Hello, I'm Sung-Hoon Kang, and I'm an assistant professor in Cyber University from Korea, and in the Department of Mechanical Engineering. And I joined this community in 2022, I guess, autumn in 2022. So I've been studying mathematics in this community for more than 3 years, and these days I'm enrolled in several programs such as differential geometry and mathematical physics, and yeah, and so on and so forth. And especially these days, I'm focusing on the pointed topology because I really don't have no idea about topology. So yeah, it's kind of starting to I am starting to study topology. And today I want to talk about the continuity of functions between topological spaces. I found these days interesting. In a single variable calculus, we often describe a continuous function in a really naive sense as drawing a graph without lifting your pencil. But in topology, this is generalized that the inverse image of an open set is an open set. Uh, this part always bugged me. it was hard to wrap my head around what it actually means for a function to be continuous when the domain or codomain is not metrizeable. So I came with the following example. I have more than 1,000 books in my room. Let's call the set of these books as X. Right off the bat, there is no obvious way to give the set X a topology. Now let's think about a function f that maps each book to its weight. The codomain y will be the positive real numbers because the weight of books is always positive. Let's give y the standard topology and just call it the weight space. Now we can give our set of books X the courses topology that makes this function f continuous, which is the initial topology. Um, from here out, I call the X the book space. So I was curious, what does it mean? What does it actually mean to say that this weight function f is continuous? Since f is continuous for any open set in weight space, like an open interval, there is a corresponding open set ready to go in my book space. Imagine someone, let's say a customer in a bookstore, comes up and asks me, could you find me all the books that weigh around 500 grams? Since I've already set up a topology in the book space based on the weight space topology, all I have to do is hand the customer the open set that corresponds to the pre-image of 500 plus minus 10 grams. In other words, because the neighborhood of each book in the book space and the neighborhood of each real number in the weight space are linked together by this function, we can comfortably call it continuous. The fun part is, if we keep the same topology on the book space but try to use a different function, like mapping the books to its page count or price, that there is no guarantee that this new function will be continuous because the neighborhoods in the book space aren't linked up with the neighborhoods in the page count or price space. This leads to another really interesting point. Suppose that there are two books in the same. Suppose that there are two books in the book space that have the exactly same weight. Since the weight function can't tell them apart, we can separate those two books topologically. Because of that, the space fails to be Hausdorff space, and which means it's not metrizeable. Mm, I hope you find my talk today interesting, and I want to give a special thanks to Professor Hyunchul Jang, who really helped me to brainstorm this example. So this is end my talk. Thank you.
That was
Just one like the information that I'd like to provide to Lisa. So the definitely know Hyuncher, right? So Hyuncher is like the guiding someone for learning topology and geometry nowadays. So someone as he expressed is now enjoying very well this like the or abstract like the language. Yeah, now Lisa, it's your turn.
that was a phenomenal example. Actually, I have not thought that much about continuous functions in topological spaces from between topological spaces in a long time, but I think even when I thought about them, I hadn't imagined them in such a kind of creative way. So that is a really great example. Um, I am curious if anything got you interested in topology in particular, or just that it was like a kind of math that I think you said you were a mechanical engineering professor, if it's just a topic that you hadn't learned about and the curiosity came from that, or
Mm, yeah, actually, there is a subject that I might I might apply the ideas of topology to. Mm, well, in fact, when I was a graduate student, one of my lab members was on the topics of um, I don't know how to call the field, but it was about to define 1 kilogram
Mhm.
in a scientific way. If you know the length of 1 meter is defined by the distance of light travels in I don't know 300 1 over 300,000 seconds. Am I right? I don't know. Am I right? But also, and 1 second is defined by the using the session 133. Uh, so it was about 20 years ago. 20 years ago. But one of my lab members was. Oh, okay. Thank you, thank you. Okay. Uh, at the time, my lab member was researching on the to define some standard units in science. So the measurement in every engineering, also including mechanical engineering, every measurement can't be exactly cannot say a 1 point exactly one real number. They always the best they can say is some range in real numbers. Like this weight is 1 kilogram plus minus 1 milligram or so. Yeah. So this studying the topology recently, it occurs to me that this measurement, every measurement is about topology, because all we can say is not an exact number, just the open interval. So I googled up if there's anyone tried to connect the ideas of topology and I don't know how to tell mm, the science to the science to define the units in science. And yeah, there was some trials, but I don't know how the engineers or scientists still do the research seriously. But yeah, I think there is a connection between the engineering and topology.
Yeah, I now hear what you're saying this with this kind of measurements and some error in intervals matches very well with your book example, right? Where the customer gives a weight and you add plus or minus 10 to create that open set. Very interesting.
Thank you.
All right, so we can move on to the next speaker. So based on this suggestion, so please.
Ga-young Kim, please.
Hello. Yeah, my name is Kayong Kim. Yeah, I am a mathematics teacher, and I entered the enjoying math 3 months ago, and I'm too happy with enjoying math. And yeah, I saw your video. Yeah, I'm impressed. I touched a sentence. At the last, I talked to you. Yeah, my script. Yeah, I am leaving algebra before starting algebra class. Equivalence relation are equivalent to partition. The first isomorphism theorem showed that each part divided by an isomorphic nucleus has the same structure. This extends to group, ring, fields, and vector space. Vector space and subspace, group and normal subgroup, and ring and idea is a pair. And the ring divided by max idea is equal to a field. Yeah, I felt like a content we have running for entire stretch. So it was strange and translating to see entire structure in 2 days because I running to yeah for a long time. Yeah, it is very yeah unbelievable. Next to algebra contact, next to class, yeah, the contents is the algebra connected to topology. Although I know the definition for each, but I felt uncomfortable with how they are connected. Why? Yeah, I heard the algebraic topology and I saw the book. Yeah, but I am uncomfortable to understood. Yeah, and as this is the FTC extend to variable multi-variable curve divergence. I believe isomorphism means in the essence of algebra. Yeah, and yeah uh yeah I am uh before I like the topology, but yeah, in the university I can I have the uncomfortable to understand. Yeah, and my major professor's major of professor is differential geometry. So he want to study to me, right uh like manifold, Riemann 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 manifold like this. Yeah, but I am very uncomfortable. Yeah, he want to talk to me about Einstein and yeah, physics, mathematics, and many times he recommended to me, but I don't like it. So yeah, my professor's major is geometry, but I changed the contents. Yeah, I choose the analysis. Yes, so I choose the series of infinite series of the real number. So I wrote that, and but I had yeah uh wish to study topology and algebra more. Yeah, and I saw your video. Yeah, with Goni. Yeah, so I touched the sentence. The sentence is that there can be light at the end on of this very long and stressful channel. Yeah, the sentence touched me. And yeah, thank you.
Good. Well, I'm glad you enjoyed the video. It sounds like the advisor wanted differential geometry, which is a hard hard field. I also struggled with differential geometry, but I'm happy that you found this algebra topic and eventually maybe algebraic topology that you are having fun now. It sounds like studying a little bit more. Um, is there is there anything in particular that made you pick up on the algebra side of things?
Now just I'm starting to
Just
study.
starting. Yeah.
Yeah.
Great. I think yeah, like going back and restarting algebra and then algebraic topology maybe eventually is like a nice way to just think about the real numbers and some of these, I don't know, abstract algebra. I feel like thinking about like the real numbers as an example of it.
Thank you.
Like the group and ring structure. It's pretty interesting. Yeah.
So one context I want to provide to Lisa is so I had a conversation with Gayang, especially this week, for whether or not from Enjoying Math YouTube channel, we think it is very important for many people who are interested like in learning mathematics. So it's important to have the good publisher not for the professional level of such like the mathematics, like the journal or those like the professional, like the educational purpose, but more like the amateur, like the mindset, writing the mathematical, like the essay of as we express what about our like the ignorance, for example, and but how we really like to feel when it comes to we are uncomfortable with the mathematical pieces that we still don't digest properly, but it's still important to leave those like the thoughts and the inspirations in the style of the either the essay or some like the books, and we feel there's no such a publisher, of course, in South Korea, but also in other like the countries that we are now considering to create the new publisher in a way to write down the mathematical essays, books, so that many people can just look at it without the hurdle from the mathematical literacy, but also they can enjoy of like the getting the ideas from those like the creators of the or the writers to really see how the people really enjoy the math, not from the perspective such as the physics medalist or those kind of elite like the professionalism. We want to talk about the how each of us can enjoy the math in our own way, but in order to do it, it could be important to indeed create the new publisher to build this type of the structure, writing the books, writing the essays, and let people from this community to work on these types of the jobs, making them to get certain profit for that. These are what we are currently dreaming of together. So yeah, that's another like the
Mhm.
context why Gayong is also looking at this algebra and topology. So this is the context I wanna offer.
Yeah.
So Lisa, do you have any thoughts?
Yeah, I think this is like a very great point. Actually, I was just talking to, I have like an undergraduate research student who's working on a paper right now, and we were just talking yesterday about um, how much he should include in his paper and how much he should kind of cut out, like the steps in between, cutting them out. And I was telling him that for his particular paper, he's going to submit it to an undergraduate journal. So I was trying to encourage him to like keep all the work in there. But he has another, he goes to another school, and his advisor at the other school is telling him like cut out all the details so that it seems like more terse and harder to understand, right? Like there are some people in the math community who purposely write their math almost so that it is difficult to understand, and um, maybe so that it looks like more impressive. Maybe it's because they think that people can fill in the gaps and they've forgotten that they've already thought about this for a long time. But I agree. I think that as a community, we could definitely make space for writing math in a way that either um, makes it easier to understand via like more details or more insight into why someone might think this way instead of just like, here's the information, like, why would you think about it this way? Um, and also maybe place for more mathematical writing that talks about how people originally thought about this. Like, you are learning algebra for the first time. What are some places that are easy to understand, and what connections did you make? And what are some places that are hard to understand, and why were they hard, and why did they go against your maybe intuition? Um, or how did you come up with an example that helped you to understand? I feel like if we could answer some of these how questions, that would be great. And on a logistical standpoint, I recently learned, maybe you all already know about these, but about archive overlay journals, I think they're called, where basically it's just like a website, right? And then instead of publishing, you just post your article to archive, and maybe this would be some way to keep like publishing costs down, but kind of create this space where the purpose is on a different style of writing than what we typically see in the math community as the norms.
Yeah, thanks for your comment. So Kayang, please suggest the next one.
정미경 씨.
Hello, my name is Lee Kyung-jung. I majored in economics and my research focuses on international trade. In particular, I study technology trade and disputes between firms or countries, and I analyze policy options the governments can consider using optimization methods. I'm not very strong in math, but I wanted to study it more seriously. So I joined Enjoying Math about 2 years ago. Currently, I'm participating in study groups on 직문수 and multivariable calculus. I'll briefly explain what I learned in this week. Uh, I'm sorry. This week, I studied the concept of inner products and orthogonality based on the material provided by Mr. Ojio. In particular, while solving practice problems, I was able to clarify the difference between the standard inner product and the more general definition of inner products. Until now, I had primarily focused on the standard inner product. However, I came to understand that the concept of inner product is not limited to vectors, but can also be extended to functions and matrices. In case of vectors, the inner product provides information about the length of vectors and the angle between them, and there they are orthogonal. At the same time, I confined that orthogonality depends on the specific form of the inner product being used. For functions and matrices, the condition that the inner product equals zero still determines orthogonality. However, unlike the vector cases, it is more difficult to develop an intuitive geometric understanding, such as angles. In summary, vectors, functions, and matrices all share the structure of vector spaces, where addition and scalar multiplication are defined. Once inner product is introduced on these spaces, properties such as orthogonality can be systematically defined. Furthermore, this framework applies not only in R2, but also in R3, where orthogonality can be interpreted more concretely through the relationship between planes and their normal vectors. Thank you.
Thank you. Well, yeah, orthogonality is a very kind of beautiful property to understand in more abstract settings. But I also appreciated that you mentioned that like orthogonality of functions is more difficult to understand geometrically, like how different things um, work together. I think a example that I often talk about the orthogonality of vectors and then the orthogonality of trig functions, like sine function and cosine function, in terms of Fourier series type settings. And it is interesting to think about how beneficial this orthogonality property can be, and how much maybe harder it is to work with functions when you don't have orthogonality. But I think thinking about the vectors is such a good place to kind of start and build up that intuition of what these things mean.
Right, thanks. Miguel, can you suggest the next one?
Next speaker, 배동성.
Hello, my name is Dong-sung Bae, and I was a teacher. I was a math teacher. I teaches. I taught math. 뭐지? High school and junior high school. Yeah, majorly. I taught not a public school, but a private academy. Yeah. I recently, no, no, I joined Enjoying Math channel about 3 years ago. Yeah, I studied uh, these days. I studied uh, Riemannian manifold and topology. Yes. And I will start my this week's study. On Wednesday in Agora Room 2, we studied a generalization of the Hessian. We first started from Euclidean space and looked at how the Hessian can be understood as the derivative of the gradient. In particular, we examined how the derivative of the gradient appears in coordinates when the formula is written using the inner product. This helped us understand more clearly where the familiar Hessian matrix from multivariable calculus comes from. Then we moved from Euclidean space to general Riemannian surface. In this setting, the usual inner product is replaced by a Riemannian matrix, and the ordinary derivative is replaced by a covariant derivative. We also discussed how the gradient of a function is defined on a Riemannian surface. Since the differential of a function acts as a linear functional on each tangent space, the Ritz representation theorem allows us to choose a vector field that represents this differential through the metric. This gave us a geometric way to understand the gradient beyond Euclidean space. Finally, we looked at why the Hessian cannot simply be defined as taking one directional derivative after another. Such an expression contains not only the second order change of the function itself, but also the change of the second direction field as we move along the first direction. Therefore, to isolate the pure second order change of the function, we need to subtract the effect coming from the change of that direction field. Through this discussion, we were able to understand the meaning of the Hessian more conceptually. I would like to thank Kang Sung-hoon, and Ryu Jung-eun and Kang Byung-soo for studying together with me. And I'm also grateful to Professor Jang Hyun-chul, for always sharing helpful advice. Thank you. That's all.
Thank you. Oh, that was very interesting. I really like how when you were speaking, you tie everything together, starting from the calculus definition up to this more abstract definition I was mentioning before, differential geometry related things and this kind of like abstract notions of these Calc 3 topics I really struggled with when I was in grad school myself. And I realized in retrospect, I think I realized a couple of years later when I was teaching Calc 3, which that's where we do this sort of Hessian introduction to our students. When I was teaching that, I suddenly went back in time and realized that when I was in differential geometry class, I had forgotten all of this uh, connection. I had forgotten all of what I learned in this Calc 3 course where I was supposed to learn. So I'm very happy to hear that. I mean, I think this is a great way to learn something that I need to work on myself of, like going back to the calculus understanding to get some sense, and then then move on from above, because hearing your explanation actually made a lot of sense to me. Um, Although if you had just started from the end, I wouldn't have remembered what a lot of these words mean. So thank you for that.
Thank you for your comment, and I'm glad to I'm glad to you're happy. Yeah. Thank you.
Okay, so please just the next one.
Okay, I'll pick 지혜 황.
Hi. I'm very nervous. Hi, I'm Jie Huang. I'm very shy about my English and my listening isn't great yet. I might ask you to repeat things. Thank you for understanding. I am a math academy teacher. My major was mathematics. Since I haven't used it in a while, I am reviewing the concept through study groups. This past week, we spent time practicing mathematical proofs related to sequence. This week I study convergence. I proved that the same sequence on converse converse to the same value even when assuming it goes to both alpha and beta. I demonstrated that sequence eventually approaches a unique limit. During the process, I clarified 이거 뭐지? the 이거 뭐지? the detective meaning of any and some. While working on this, I learned to distinguish between direct proof and proof by contradiction. I felt much more comfortable when I switched to a direct proof after interior trying contradiction. Also, although it seems obvious that a sequence goes to the same value, it still required the triangle in inequality and the theorem of convergence. Thank you.
Thank you. First, I really like your Zoom background, the background on Zoom. Um, Second, yeah, that was a very nice talk. I think this looking at sequence converging to a unique limit is um, a nice proof. And I also liked that you mentioned both direct proof and proof by contradiction as ways to think about sometimes the same problem, right? Can we prove the same statement two ways? And what do we maybe learn about the arguments via trying to prove the same thing two different ways. I am actually teaching real analysis in the fall in next semester, and I have been thinking a lot about how important it is to let students maybe read different types of proofs, or it sounds like for you, try different types of proofs for the same outcome. So some topic that some statement that we want to prove, seeing different ways to get to the same answer. So I'm happy to hear it. It sounds like the comparing the proof by contradictions and the direct proofs was a useful experience for you.
Thank you. Next time, Inhu-chan.
Yeah. I really love it. Yeah. My name is Inho. Yeah. I have 15 years of experience working as a fundraiser in NGO. And I'm also a social worker. Yeah. And I studied the social welfare and philosophy. And I'm particularly interested in issue of inequality. Yeah. Looking back on my life, I didn't have a strong mathematical background. Yeah. However, I wanted to learn mathematics because I often felt limitation when working with data analysis. And last year, I joined the community and enjoyed the math. And last summer, yeah, at the time, the open the course, yeah, some 질문수, yeah, the course 질문수 introduced the fundamental concept of modern mathematics. And through this course, I was able to understand mathematics again from a new perspective. And last Tuesday, the 질문수 course was finished. So at our next step, I plan to study calculus and linear algebra. Yeah. Yeah. Also, listening to and speaking mathematics in English is still challenging for me. I was working on improve by practice is script. Yeah. So I started. Yeah. This week, I spent some time thinking about inner products, especially the relationship between perpendicularity and orthogonality. As we know, an inner product allow used to define geometric idea such as the length and angle. In this setting, two vectors are said to be orthogonal when their inner product is zero. And in Euclidean space, we often interpret this as being perpendicular. However, I thought to the question, why the value zero is so important? At first, I was thinking in terms of correlation in data analysis. We usually try to find variables that are strongly related, so I didn't immediately understand why we should care about variables that have no direction. But after thinking more carefully, I realized that orthogonality is actually essential for understanding structure. When two vectors are orthogonal, one has no component in the direction of the other. Because of this, we can split of the vectors into independent components and analyze each part more clearly. This idea is closely related to prediction in linear algebra. This leads to me think more carefully about the difference between perpendicular and orthogonal.
In Euclidean space, they are essentially the same because the linear inner product uh, directly reflects geometric angles. But in more general setting, orthogonality depends on how the inner product is defined. So even if something does not look like 90 degrees angle to you, it can still be orthogonal within that space. This made me realize that perpendicular is more of a geometry in distinction, while orthogonality is more general mathematical concept. I found this question interesting, and I would like to explore more example about how it appears in different areas, such as the data analysis or more abstract space. Yeah, that's the end. So when I was finished the discussion, I was thinking about that point. Yeah, I came to the realize that in the vector space, yeah, each data point can be represented as a vector, and in a product to help describe relationship between them. Yeah, by separating orthogonal components. Yeah, did with zero in a product. Yeah, we can better focusing on the directions that are relevant uh, relevant for the building models such as regression. Yeah. Thank you. Thanks for listening. Yeah, thank you.
Thank you. Yeah, that's very interesting. Linear algebra is a great field to learn for data analysis, right? Of these two fields are, I mean, it is like the math behind a lot of data analysis. And I think that's a good point. It sounds like what you're saying at the end is like, yeah, if maybe a data points collect a lot of different pieces of information, right? And you're trying to build this model, you only want to focus on certain ones of these components, and the orthogonal relationship between things can help you to separate. Even thinking about like, yeah, if you have like height and weight and you put them into a vector, you put one in the first component and one in the second component, and you graph these, and the height goes in one direction and weight goes in the other direction, right? And these are kind of separate concepts. They're not originally connected, and then the data analyst decides, is there a relationship between them, some sort of linear relationship? Yes, I think linear algebra, this orthogonality is a great direction to go in.
Yeah, thank you. Thank you for your advice. Yeah, thanks. Yeah, next person who, yeah, it's Chaeyoung Lee. Yeah, Miss Chaeyoung Lee. Yeah.
Hello, Professor Naples. My name is Chaeyoung Lee, and now I'm undergraduate student, but I take gap year to get literacy of my major AI. So I just started to study mathematics with bottom up. So this week I spend my time solving preparation problems for the upcoming KIDASU program. I was able to complete the next lecture one problems by investing most of the day, but the lecture two problems require multiple attempts over an extended period. The problem requires finding a counterexample where two sets are not equal, utilizing the definitions and types of function. Through repeated try and error, I found myself writing out the function definition multiple times. By categorizing the problem into injective, surjective, and bijective cases to find a counterexample, I repeatedly reinforced my understanding of each definition. Watching the lectures and solving proof problems initially brought some tension due to my lack of prior experience. However, navigating through this difficulties allowed me to familiarize myself with the definition and gain clarity, effectively overcoming that initial hesitation. As I participate in the study, my goal is to move beyond simple reflection and develop the ability to express my problem solving processes using formal mathematical language. Thank you.
Yeah, this is an interesting process, right? To learn how to absorb definitions that show up in math and really process them. And I'm happy to hear you kept trying through your problem to understand the definitions better via examples. I think that's a great approach to take to actually try the definitions and use the definitions until you understand them instead of just reading them over, right? We have to try them. So I'm glad that that sounds like it's been a useful experience for you.
Thank you. So I like to suggest Rocky Kim.
I'm Rocky Kim. Uh, I I joined this community in this year. Uh, I want to uh, talk about the experience in colloquium. This colloquium is from bad teacher, maybe bad, bad teacher. I very enjoy this community. For example, I heard the word geometric measure theory by Professor Jang Hyun-chul, but I don't know about it. The context is very simple. He say about the homological problem, maybe. And his example is think about a torus and think about let's find minimal curve. This is this is one. We can generalize this problem, homological problem, but it cannot hold if dimension larger than 8. But I but there is many in curious curious thing anyway. And I'm a software developer for now, and I'm and okay. I want to start my script. Last Saturday, I participated the colloquium and met several teachers. I gave a presentation where I introduced finding the greatest common divisors integers as uh, as a medium for observing the addition of ideas. More specifically, I had thought that I should show the actual computation of two integers using the Euclidean algorithm, but I kept choosing examples that were too easy, like 42 and 12. Uh, and I remember laughing and saying, why does this end in one shot? For me, this calculation feels like it shows the properties of ideas after the curriculum in the beauty of algebra. The teacher who runs the channels said that ideas are about solving systems of equations since the problems of finding common divisors in the integers changes in the polynomial case into the problem of finding common roots, I came to think that looking at it as problem of solving system of equations is also a natural step to take. Listening to the teacher's presentation mm, at the colloquium was good, but the conversations afterwards stayed with me even more. At a cafe, I talked with Kim Namu teachers who had presented the Weierstrass representations of minimal surfaces about our impressions of the details involved in computing the variation surface area. I had gone through uh, a similar experience myself, so it was very enjoyable. In my case, I had also need to expand square root 1 minus s using a Taylor series, and I remember getting stuck thinking, what is this? When Kim Nam-ho teachers also brought up that story, I felt a very strong sense of connections. I had been very curious about why in the details of being minimal surfaces from the perspective of complex analysis. One has to switch to complex numbers at all. While talking with him, I picked up a clue that this may be connected to stereographic projection, so I came away with something new to check, and that gave me a lot of expectation. Thank you for listening.
Thank you. That sounds like you had a lot of interesting conversations and a lot of curiosities that came from trying one thing and then learning the next step. I like this story about the um, greatest common divisor algorithm and then leading to polynomial question and thinking about how things work in similarity. Um, and also your comment about trying examples that maybe at first the examples that you try, the natural ones are too good of examples, right? And things work kind of too well, and so you get a little tricked in seeing the complexities of things until you try further examples. I think that is something that happens so often in math. At first, we want to try the examples that make sense to us. I find this a lot. So in my work, I draw a lot of pictures. And of course, I draw the pictures that I can think of. And these pictures, they are often too good. And so I can use them, but then I try to prove something and it doesn't work. And then I realize afterwards it was because my picture was too good. Um, and there is so many more questions that I can ask if I make my picture a little bit worse.
So I'd like to put two like the distinct like the context to Lisa to share your thoughts before we finish the recorded conversation. So one is one context I wanna share for Loki to Lisa is so he so far has been studied in South Korea and he's currently as he introduced himself as a software developer, but he did the CS for his like the bachelor degree and did the master in pure mathematics. And then he just decided to work in the company and he's currently working on it. But through the experience of this community, he more realized that he want to study PhD level of mathematics for his like the challenge and career. But I should say because he's considering to move into the state of Texas to get the guidance from me. And Lisa is very close friend to me so that you can share so whether or not this could be either completely doomed or could be good possible like the potential choice. That's the one thing I want you to share your brilliantly honest like the thoughts about it. And another like the part is so because I'd like to advertise your study in the community. So sooner or later, then once you want to organize the study group that you prefer to share, so that can be also advertised from the recorded video so that that can be seen from this like the channel for sure, but at the same time for your own like the students and also the people that they want to watch what you'd like to organize so that you can use this opportunity to advertise what you are aiming for. Yeah, those two things are what we want to do before we start to record today.
Okay, so first of all, I think I think that is a very great match that you are thinking of PhD student, it sounds, and advisor. I think that will be a great opportunity. Um, and then, yeah, in terms of the yes, the like reading group idea or project group idea, I could start with some papers. So mostly the things that I do in my research are related to things like parameterizations of non-smooth curves. So finding functions from, say, the unit interval to a set, and then thinking about the properties of those functions. So we talked about continuity before, right? Or topological space to topological space. Often I'm working in Euclidean space. So is there a map, a function that goes from unit interval to the set? And then what are the properties of that function? Can we get a Lipschitz map is what we're normally interested in, or a Holder map? And then related concepts to this. So for example, what is the best Lipschitz map that we can use to approximate a set? So I would be, yeah, happy to maybe start with a paper on this if people were interested in reading, and then maybe trying to work on some project related to this over the summer. I also am very happy to hear that there are like teachers in the group. I am very interested in math education also. And I think another thing, and I don't know how this fits into your community, but um, I've been reading a little bit about how things like real analysis, so like proof-based real analysis can fit into classroom level, like middle or second, I don't know, what is middle school called? High school education. So how can we use like our more advanced knowledge to better explain to our students, the younger students? So if any of the teachers in the group are interested in talking about this at all, that is something that I would love to have conversations about also.
Yeah, thanks for sharing your like the interest. So yeah, I should definitely try to organize such a, like a group of conversation. I might invite you after this conversation to the Discord channel so that you can also like personally discuss with the people who are interested in like the communicating with you. So yeah, before we finish this like a recorded session, just two things. So one is from the friends of Buhyun. So because you guys are just super have listened. So if you guys just want to share any thoughts or how do you really feel by joining this conversation, so that's one thing we'd like to hear. And Lisa can just express so how do you really like to enjoy this our conversation as just a end like the comment. So can you just first like use up
Sure.
and your friends go over first?
Yeah, I just want to say it's I'm really excited to be part of this group, and I'm willing to yeah to study more because as I said, it's right now as a bachelor student, all of what I see in maths was a bunch of curiosity, and I'm really curious to understand because there are many topics that we still don't
Yeah, we're interested
encounter yet,
second
but yeah,
semester.
we just curiosity and that's what drives us, I would say.
Yeah. Do you want to say something? Yeah. Also, like,
Yeah,
Sergio?
I just think that it is also a great way to stay motivated because you have people who are also enthusiastic about the topic and you can discuss things, etc. And I just think that this will keep you motivated.
Sorry, so you're unmuted, not on purpose. I don't know. We cannot hear.
During the
Yeah,
semester.
now we can hear you. Yeah, please go ahead.
I was saying that I think it is a great way to stay motivated because you have other people who are also interested in mathematics and you can discuss the topic with them, and that will keep you
This kind of algorithmic, I don't know.
engaged throughout the semester. Yeah.
Yeah, so I can
Okay.
share the link of the Discord channel to Bohyun so that you guys can also join and we can make some further conversation to whether or not we might organize more like the interest in like the small study groups that Bohyun's like the group can be launched to study something together. I will definitely actively consider it so that please just try you guys can contact me in person for sure, but at the same time I'll try to make the conversation with Boyan so that you guys can chat for that. Yeah, so last one. So Lisa, so please share how you feel from this experience.
Yeah, I'm very grateful to have spent the time with you today. I think it's very nice for me to hear that so many of you are studying math purely for the interest in it and not even for like career stepping stone, just like just pure interest. Um, that's very inspiring to hear that that there are so many people who are excited about learning and thinking about why things work the way that they do and using kind of situations in your real lives where maybe you realize you wish you can understand things and taking action to actually understand what is going on beyond those things.
Yeah, we truly appreciate Professor Naples to contribute our conversations and feedback, and we wish we might see her not in the like a regular basis, but time to time from this community. Yeah, and thank you very much for everyone. I will stop the record here.